Okay, logarithm rules. I think we're moving into 3.3 here. 3.3 and 3.4 is logarithm rules. So logarithms and exponentials are inverses, and that has two identities that we can remember. The composition rule about inverses: if f of x and g of x are inverses, then f of g of x is x, g of f of x is x. So if we think about cubing cube root, f of x equals x cubed, g of x equals x to the 1/3 of the cube root. These are inverse functions. F of 3 is 3 cubed. That's 27. So what point is on the graph of y equals x cubed? Point 3 comma 27 is on the graph of y equals x cubed. There's my x, there's my y. G of 27, what's the cube root of 27? Well, that's 27 to the 1/3, but the cube root of 27 is 3. Not a big surprise. So what point is on that graph? X is 27, y equals 3. Right? And we've seen that before. Inverses, you switch the x and the y. So f of g of 27, how do you calculate that? You calculate g of 27 first, and we know that g of 27 is 3. What's f of 3? F of 3, we plug 3 into x cubed, and you get 27. This isn't a big surprise. If you take the cube root of 27 and then cube the result, you start with 27, you get 3, and then you come back to 27. Same thing that g of f of x, g of f, g of f of 3, right? F of 3 is 27. So you calculate that first and you plug it into g. G of 27 is 3. So if we take 3 and cube it and then take the cube root of the result, you just come back to 3. So in general, f of g of x means taking g of x, which is the cube root function, and plugging it into the cubing function. Cube root is x to the 1/3. Cubing is x to 3. What do you get? Well, 3 times 1/3 is 1, so you just get f of g of x equals x. G of f of x means taking the cubing function and putting inside the cube root function. But that just gives you back whatever you started with. So if you have inverse functions and you do one and then the other, you just come back to where you started, right? F takes you from 3 to 27. G takes you from 27 back to 3. So if you do this and then this, you just come back to where you started. So a similar thing you get for exponentials and logarithms. B is any positive number except b equals 1, right? You can't have 1 as your base because 1 to the anything is just 1. So if your base is just 1, you have a horizontal line, y equals 1. So f of x equals b to the x and g of x equals log base b of x. These are inverse functions. So f of 0, anything to the 0 is 1. So what point is on the graph of y equals b to the x? 0, 1. What is g of 1? That's log base b of 1. Two different ways to think about it. This is asking for a power, like we talked about in the previous lecture. What power do you raise b to get 1 out? Right? B to the what equals 1. And that's 0. That's the power b is raised to get 1. B to the 0 equals 1. Or you can just remember that exponentials and logarithms are inverse. So if this is a point on the exponential graph, that has to be a point on the logarithmic graph. So f of 1 equals b to the 1 equals b. So the point 1 comma b is on that graph. G of b, though, is log base b of b. What is that equal to? Well, what power do you raise b to get b itself? Or just 1? So b comma 1 is on the graph of that log. And note, we're just flipping the x's and y's. So What does that mean in terms of compositions? Well, f of g of x equals x. That's the basic about inverses. If these are our two functions, this becomes f of log base b of x, because that's my g. And then what does f do? Well, it takes whatever input you got and it just puts it up into the exponent. So b raised to the log base b of x equals x. And there you really see that logarithm is a power. This number, whatever it is, it's the power that you raise b to get the number x. We also know that g of f of x equals x. So f of x is b to the x, so g of b to the x equals x. But g takes whatever input you give it and takes the logarithm of it. So we get log base b of b to the x equals x. So what is this number? It's the number that you raise b to get b to the x. But what do you raise b to get b to the x? Well, you raise it to the x. So that's the inverse properties. Log base b of b to the x equals x, and b to the log base b of x equals x. If you have the same base here and here, then the output is whatever the exponent is. If you have the same base here and here, then the output is whatever is in the logarithm. And then you also have the fundamental rule. So this gives us two rules about logarithms. Oh, and also we have special points. So this is sort of summarizing what we've done here. Exponential graphs go through 0, 1, and 1b. Logarithmic graphs go through 1, 0, and b to the 1. B to the 0 equals 1, right? That's this point. It's the same thing as log base b of 1 equals 0. It's that point. B to the 1 equals b is the same thing as log base b of b equals 1. Right? So fundamental rule, inverse properties, fundamental rule, inverse properties, and special points on exponential logarithmic graphs. So as we noticed before, base e logarithms are written as ln. So log base e of x is ln x. This is a notation. Base 10 logarithms are written without the base as just log. So log base 10 of x, we usually don't put the base there, it's just log. For every other base, we include the base as a subscript. So base 7 logarithms are written as log base 7 of x. So to calculate the following, log base 14 of 14 to the 1, same base here and here. So that means we can use this rule. Log base 14 of 14 to the 1, that's just 1. Log base 14 of 14 cubed. So log base 14 of 14 cubed, that's just going to be 3 because it's just the power. 14 to the log base 14 of 3. Right? 14 to the log base 14 of 3, same powers here and here. So it's going to be 3. This number, right, log base 14 of 3, that's the power that 14 is raised to get the output 3. Okay. So you have to be a little bit careful in dealing with logs with the notation here. Log 100, keep in mind that without the base, that means we're dealing with base 10, and 100 is 10 squared, so log base 10 of 10 squared, that's going to be 2. E to the ln of 32, remember that ln is log base e of 32, so we have the same base here and here, and so the answer is just 32. Ln of e squared, remember that ln is log base e of e squared, and if we have the same base here and here, the log of the base raised to a power is just the power itself. So that's starting some rules about logarithms. That's why it's logarithm rules 1. There is, of course, a logarithm rules 2, which is coming up next.